Now we go on to look at dividing surds. As far as operations with surds are concerned, dividing sort we've looked at addition and subtraction, we've looked at multiplication. Now it's time to look at the division of surds. So after this lesson, you should be able to divide square root expressions, use the rule square root of a divided by square root of b, write answers in simplest radical form, and simplify fractional surds, and then you be able to rationalize denominators containing surds. So again, we remind ourselves of what surds are. A surd is a root, usually a square root, that cannot be simplified into a rational number. Examples: root 2, root 3, root 5, root 7. We can have smaller, higher roots like root 3. We can have square roots too. All these are square roots, right? We can have higher roots like cube root, third root, fourth root, fifth root, and so on and so forth. But usually square roots, right? So these numbers are irrational, meaning they cannot be written exactly as fractions. However, they follow algebraic rules that allow us to simplify and manipulate them. So these sorts, they actually they behave like variables x and y and z and all of that in algebra sometimes, as you've seen before now. Okay, so what is the rule for dividing sorts? Imagine the key rule is this, that the square root of a all over the square root of b is equal to the square root of a over b. That is the ratio of a sort, or the ratio of two sorts is the okay. Maybe this is not going to make sense because I mean, once you divide, things can change. So, after when you put everything under these square roots, you cannot be sure that a over b will also be it will also be irreducible, so to speak. That you cannot factorize the square roots out of it. So, that statement going to be correct. But I mean, square root of a over square root of b is equal to square root all of a over b. All right, this works because square roots can be written as powers. For instance, we have square root of a is a raised power half. Therefore, if you have a raised power half over b raised power half, that's the same thing as a over b raised power half. So that means that square root of a over square root of b is the same thing as square root of a over b together. So you have an example here. Example one, you have you want to simplify square root of 16 all over square root of 4. Of course, this one is still straightforward because square root of 16 is 4, square root of 4 is 2. So 4 over 2, the answer is 2. But then if you want to do it in form of surds, right, using the rule we have looked at, so we combine under one radical. So we have square root of 16 over 4, which is 16 over 4 is 4. So square root of 4 is 2. And the final answer is 2. Same thing as if you had done it separately. Then here, if you simplify, you have square root of 18 all over square root of 2, right? So you can combine everything and you have square root of 18 over 2, which is square root of 9, and that is equal to 3. So the final answer is 3. So an alternative approach would have been to have square root of 18 all over square root of 2, and we know that this is square root of 9 times 2 all over square root of 2, and this is equal to square root of 9 is 3. So you have 3 root 2 all over root 2, and root 2 cancels root 2, and the answer is 3. So that's another way you could have that could have been done, right? So there are several ways of doing some of these things sometimes. So we know the answer is simply 3 here. For example, 3 now, imagine this. You have you want to simplify square root of 12 over square root of 3. You could do the same thing I did over there. You know, this is simply 2 root 3 over root 3. Root 3 cancels, you just have 2. Or you can combine it. So you have square root of root 3, square root of 12 over square root of 3. That is square root of 12 over 3. That's square root of 4 because 12 over 3 is 4. And square root of 4 is 2. Straight up. Then here, we then talk about the idea of simplest radical form. I think we had mentioned it in a previous video, but it's good we are seeing it again. So simplest radical form, a solid is in the simplest radical form when the number inside the radical has no perfect square factors except 1, and then the radical is fully simplified. That means you cannot simplify it further, and the denomination does not contain a radical. All right. So let's see how this plays out. In example 4, you want to simplify root 50. You know, you factor 50, right? In a previous video, we had talked about factor trees, where you keep dividing until you get the number as a product of its prime as a product of prime factors. So 50 is 25 times 2, for instance. This is the biggest square root. So applying the square root rule, you have root 50 to be the same as root 25 times 2. And root 25 times 2 is the same thing as root 25 times root 2. And root 25 is 5. So you have 5 root 2. So 50 now. So this is the simplest radical form now. This is the simplest radical form. So going forward, we can actually also have root 72. So for root 72, the biggest square root is 36. So you have root 36 times root 2, that's 6 root 2 easily. Then you can also simplify fractional surds, right? Because we are dividing, as you know. So a fractional surd is a surd written as a fraction. That's root 3, 12 over root 3, which is root 12 over 3, which is solve for that square root of 4, which is simply 2. So a fractional surd is written in that form. So what of this one now? You have root 5 over root 45 over root 5. That's root 5. I mean, root 45 over 5, which is square root of 9, because 45 over 5 is 9, and square root of 9 then is 3. So then we go ahead to talk about the idea of rationalization, okay, which is really important. So rationalizing the denominator, sometimes the surd appears in the denominator, like you have 5 over root 2, and it is not pretty to have a surd in the denominator. So you want to rationalize it to remove it because it is easier to divide by a whole number than to divide by a radical. So mathematics convention requires no radicals in the denominator. So, that's the third condition when we talked about the simplest form. So we said there that the denominator does not contain a radical. So in this case, now we have a radical down there. So you have 5 over root 2. So to remove it, you multiply by the same radical. So in this case now, you have 5, example, you want to simplify 5 over root 2. So multiply top and bottom by root 2. So why are we doing this actually? So you have 5 over root 2 and you want to rationalize. Uh, so we have 5 over root 2. Now, rationalization is simply rewriting this 5 over root 2 in another form where we don't have a radical under. And for you to do that, right, you have 5 over root 2. So what will you multiply this by so that it wouldn't have changed the way it is? So it's more or less like you're multiplying this by 1, okay? And if you multiply 5 over root 2 by 1, nothing has changed. And 1 can be in any form. But what will inform the form of your 1 here will be this root 2 down here, okay? So you can then say this is 5 over root 2. So in place of this one, now you now have root 2 all over root 2. Root 2 over root 2 is still 1. So nothing has changed technically. And the reason why we're doing that is that by multiplying root 2 by itself, the root disappears and we have just a number that can, a whole number, right? So you can then have 5 times root 2, that's 5 root 2. Root 2 times root 2 is root 4, okay? And that is 5 root 2 all over 2. So this one is easier now to handle than when you had a root under there. So you could actually go ahead and say this is 2.5 root 2 if you like. So, but usually you can leave it this way, 5 root 2 over 2. So if you evaluate, you discover that these two are exactly the same. In fact, I want to do that with Desmos, 5 over root 2 being 5 root 2 over 2. So let's check that out with Desmos, that they are equivalent expressions, but the second one is easier to handle than the first. So let's go Desmos. Okay. Yeah. So we have 5, 5 divided by square root of 2. Square root of 2. That's 3 points. Let me even do the normal graphing thing. So let me go Desmos again. Desmos. Yeah. So we can see everything together. So you can see they're the same. So you have 5 divided by square roots of 2. So you have 3.53, blah, blah, blah. And then you now have 5 square roots of 2, 5 square roots of 2 divided by 2. So you see, they are exactly the same. But now this one is easier to handle than 5 over root 2. So because by rule, we don't want to have a radical at the denominator. So the final answer is 5 root 2 over 2. So in example 8, same thing. So you have 3 over root 5. That's 3 over root 5 times root 5 over root 5 because of the root 5 here. So you have 3 root 5 over 5. And that's the answer. Again, 3 over root 5, right? You have 3 divided by square roots of 5. And then as compared to 3 square roots 5 divided by 5. like this. So you see the same thing. They are exactly the same. So example 9 now, we have a mixed example here. So for this now, we have square root of 75 over square root of 3. So here you can easily divide 75 by 3 and you get square root of 25, which is 5, straight to the point. For example 10, we can have this also. We have 4 roots 18 over 3 roots 2. So for 4 roots 18 now, so root 18 itself, that's 3 root 2. So 4 root 18 is 4 into 3 root 2. And you have 3 root 2 down here. So 3 root 2 can cancel 3 root 2. And all you have left is 4. And that's the final answer there. So we have the key rules now when we talk about dividing sorts. So we have the key rules. The division rule, square root of a over square root of b is equal to square root all of a over b. Then product through square root of ab is equal to square root of a times square root of b. And to rationalize, the rationalizing rule is 1 over root a times root a over root a helps to rationalize 1 over root a into an equivalent expression that is equal to it. So practice problems now. Um, Okay, so maybe we have to consider this in fives because they take a bit of space. So so some of them we can just look straight and answer without even putting pen to paper, so to speak. So root 20 over root 5, of course, that'll be root 20 all over 5, that's root 4, which is simply 2. Then root 18 over 2, that's root 18 over 2, which is root 9, which is 3. Root 45 over 5, that's root 9, that's 3. Root 32 over 2, that's root 16, and that's 4. Root 63 over 7, that is simply root 9, which is 3. So that's question 5 there. Then 6 to 10 now. Root 75 over 3, we did that before. That is root 75 over 3, which is root 25, which is 5. Root 98 over 2, that's root 49, which is 7. Root 78 over 8, that's root 9, which is 3. Root 27 over root 3, that's root 27 over 3, which is root 9, and that is 3. Root 100 over 4, that's root 25, and that is 5. Okay, so all these ones are still easy to handle. Um, okay, so I think we've got to that point where we may need to put pen to paper. What do we do? Um, Okay, so okay, maybe I should just continue what I was doing. 5 over root 2, of course, will be 5 root 2 over 2. 7 over root 3, 7 root 3 over 3. 9 over root 5 is 9 root 5 over 5. 4 over root 7 is 4 root 7 over 7. 6 over root 11 is 6 root 11 over 11. And then from 16 to 20 now, things are a bit more serious, but we can still do it like that. So this is 3 root 20. 20 is 4 times 5. So that's 2 root 5. That's 3 times 2, 6. So 6 root 5 over root 5. That's the answer is 6 there. Mm, then coming down, I'll do 19 and 20. So I'll do 19 and 20 by writing, but these ones, let's just go on for now. Then here we have 4 root 18 over root 2. Okay, in fact, instead of wasting time the other time, I could have just have said 3 roots 20 over 5. That's 3 roots 4, which is 2. 3 times 2 is 6. Easy. That's even easier. 4 root 18 over 2. So we can just divide it 2. So we have 4 root 18 over 2. That's 4 roots 9. That's 4 times 3, 12. Answer. Then 5 over 2 here. So you have 5 roots. So you have 5 over 2. Then root 12 over 3, that's root 4. So 5 over 2 times root 4, that's 5 over 2 times 2. The answer is 5 at the end of the day. Then here, I can even do everything like that, like without even touching pen. So here you have 6 times root 27. Root 27, okay, we can even do this. 6 over 3 times which is 2 already, right? And root 27 over 3, that's root 9, which is 3. So this is 2 times 3, and that is 6. Okay, well, let me just do this other one like this. So 8 over 4 times 8 root 50 over 4 root 2. 8 root 50 over 4 root 2. So 8 root 50 over 4 root 2. So here we can just have 8 over 2 multiplied 8 over 2, in short, root 50 over 2. 8 over 2 is 2. 50 over 2 is 25. So we have 2 root 25. That's 2 times 5. Square root of 25 is 5, and that is 10. And that's how that goes, like that. Okay? So as we go on, we'll see more, we'll be learning things like conjugate and all of that. And we have more serious situations like that. So don't forget to try your hands on these practice questions to really see if you grasp the you get the idea like this. So with this, I come to the end of this interesting video on dividing swords. So dividing swords. Yeah, I think well, imagine if you have something like this. So you have root 2 over root 3, right? So how do you handle this? You rationalize again. You have root 2 over root 3 times root 3 over root 3. Now, mind you here, you have to be careful. It is the denominator you are getting rid of, not the numerator. So whatever is at the top is not your problem, but the one at the bottom is your problem. So the uh, denominator is the big deal. Okay, denominator, not the numerator. Okay, the focus is on the denominator. So that's why I think this is even very good that I'm doing this. So you don't get confused about that. So here now you have root 2 times 3 all over root 3 times 3. So root 2 times 3 is root 6, and that cannot be simplified further. Root 3 times root 3 is root 9. Okay, and that is root 6 all over 3. And that is it. So root 6, so root 2 over root 3 is root 6 all over 3. So we can also compare the two. Root 2 over root 3 is root 6 over 3. So root 2 divided by root 3 is that, and then that's root 6 all over 3. Exactly the same thing. Okay. So yeah, finally we come to the end of this interesting video about dividing surds. So try your hands on these questions to be sure you get the gist. Okay. So let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed to this channel already, I thank you very much for doing that. But if you have not subscribed, what exactly are you waiting for? Go ahead, subscribe, hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of the channel by clicking on join, and that gives you some special privileges. Um, like getting to see some videos first or being the only one to see some videos as members of the channel. You can also request for PDF copies of my notes. You can we can also hang out to discuss whatever interests you on this channel and all that. So we can do so many things together. So let's go on and build this community together. Ultimately, don't forget to comment, like, share, so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.